Imagine a point in space where gravity is so strong that time stops and space is infinitely curved. Welcome to the world of space-time singularities. Taking a leap into the realm of the incomprehensible, we find ourselves grappling with the concept of space-time singularities. These are points in the universe where our understanding of physics as we know it breaks down. They are the mysterious hearts of black holes, where gravity becomes so powerful that it warps space and halts time. As we delve deeper, we stumble upon the extraordinary theory of general relativity, crafted by Albert Einstein. This groundbreaking theory has boldly predicted the existence of these space-time singularities. According to general relativity, when a massive star exhausts its nuclear fuel, it collapses under its own gravity, creating a black hole. At the core of this black hole, all of the star's mass is compressed into a single point of infinite density. This point, this singularity, is where the laws of physics as we know them cease to function. Now, you might wonder, how can something be infinitely dense? Or how can time come to a standstill? These are the questions that baffle even the brightest minds in physics. The truth is, we don't entirely understand what happens at these singularities. They are like the edge of a map, marked with the phrase, "Here be dragons." They are the frontiers of our understanding, inviting us to venture into the unknown. But fear not, for we are not entirely in the dark. Various theories attempt to explain the enigma of singularities. Some suggest that they might be gateways to other universes, while others propose that they could be the birthplaces of new universes. These are the exciting possibilities that we will explore as we journey through the world of space-time singularities. Now, if that doesn't make your head spin, let's dive into 10 surprising facts about these fascinating anomalies. Surprising fact number 1, singularities are inevitable. In the universe's grand tapestry, singularities are not just a mere possibility, they are a certainty. This was demonstrated by the Penrose-Hawking singularity theorems, a groundbreaking work by two brilliant minds, Roger Penrose and Stephen Hawking. The theorems, rooted in the theory of general relativity, tell us that whenever there's a sufficient concentration of mass or energy, a singularity, a point where space-time becomes infinitely curved, will inevitably form. In layman's terms, it's like a cosmic traffic jam, where everything gets so dense that the universe effectively crumples under its own weight. These singularities are typically found at the heart of black holes, those eerie, light-swallowing monsters that lurk in the distant reaches of our universe. However, they could also be hidden in places we least expect. So it seems we're surrounded by these mysterious phenomena whether we like it or not. Surprising fact number 2. The universe might be hiding its singularities from us. This is where the cosmic censorship hypothesis comes into play. It's a theoretical proposition that suggests all singularities, those places where gravity becomes infinitely strong, are hidden from us, concealed within the event horizons of black holes. Think of it like this. The universe has a cosmic curtain that it draws closed to shield these extreme points from our view. It's as if the universe has its own sense of modesty, protecting us from the raw, unfiltered reality of infinite gravity. These singularities are not for the faint of heart. They are where our understanding of physics breaks down, where the fabric of space and time becomes a Gordian knot that we are yet to untangle. It seems the universe has its own modesty after all. Surprising fact number 3, not all singularities might be hidden. Yes, you heard it right. Welcome to the wild world of naked singularities. These are theoretical oddities, potential exceptions to the cosmic censorship hypothesis, which suggests that every singularity is cloaked by an event horizon, the boundary of a black hole beyond which nothing, not even light, can escape. But what if that's not always the case? Picture a singularity, stripped bare, with no event horizon to shield it. This is a naked singularity. It's singularity gone rogue, defying the cosmic dress code. And if they exist, they could potentially reveal the inner workings of the universe, providing a window into quantum gravity, a realm untouched by our current understanding of physics. However, while the idea of naked singularities is intriguing, it's still highly speculative. There's no concrete proof they exist, but their potential existence challenges our understanding of the universe and its laws. So the universe might not be as modest as we thought. Surprising fact number 4. Quantum physics might rescue us from singularities. Now, this is where things get really interesting. In the realm of the very small, quantum mechanics reigns supreme. This is a world where particles can exist in multiple places at once, where they can pop in and out of existence, and where the act of observing can fundamentally change the nature of reality. It's a strange, counterintuitive world, but it's the world that underpins everything we see around us. Now, let's bring in the big guns: quantum loop gravity. This is a theory that attempts to reconcile the macro world of general relativity, which describes gravity and the large-scale structure of the universe, with the micro world of quantum mechanics. In essence, it's a theory that attempts to describe gravity at the quantum level. According to quantum loop gravity, the fabric of space-time is not a smooth continuum, as Einstein's theory of general relativity would have us believe. Instead, it's made up of tiny, discrete loops. Think of it as a fabric woven from the tiniest threads possible. Here's the kicker. If space-time is made of these tiny loops, then it's not possible to have a point in space where gravity becomes infinite, a singularity. The loops just won't allow it. Instead, what you'd have is a region of incredibly high but finite density. This is a radical departure from our current understanding of black holes and singularities. And while it's still just a theory, it's a theory that's gaining ground. It could revolutionize our understanding of the universe and provide answers to some of the biggest questions in physics. So, could quantum loop gravity save us from the mind-bending, incomprehensible infinities of singularities? Well, it's too early to say for sure. But one thing is certain: quantum physics continues to surprise and confound us at every turn. So, quantum physics might be our knight in shining armor against these space-time monsters. Surprising fact number 5. Singularities might be destroying information. Now let's dive into one of the most contentious and intriguing facets of singularity theory: the black hole information paradox. This concept throws a curveball at our understanding of physics. And it all starts with a fundamental principle. In the realm of quantum mechanics, information cannot be lost. Imagine you're throwing an encyclopedia into a bonfire. From our everyday perspective, it seems like the information within those pages is destroyed, right? But from a quantum viewpoint, the information is merely transformed. It's encoded in the light and heat radiating from the fire, and in theory, with enough knowledge about the particles involved, you could reconstruct the encyclopedia. Now, let's take this scenario to a cosmic scale. Replace the encyclopedia with a star and the bonfire with a black hole. When the star crosses the event horizon of a black hole, it's seemingly lost to us forever. But what happens to the information it contained? Here's where things get really interesting. According to the principles of quantum mechanics, the information about the star should still exist somewhere. But black holes, as we know them, don't play by these rules. They seem to swallow up stars, planets, even light, without leaving any trace of them behind. This is the crux of the black hole information paradox. The late physicist Stephen Hawking proposed that black holes might emit radiation, now known as Hawking radiation, which could carry away some information about what has fallen in. However, this hasn't fully resolved the paradox, and the fate of information within a black hole remains one of the biggest mysteries in modern physics. If singularities are indeed destroying information, they're not just bending the rules of the universe, they're tearing them up entirely. They become not just infinite points of gravity, but also the universe's greatest shredders, compacting and obliterating information in a way that we currently believe is impossible. It seems singularities might be the universe's greatest shredders. Surprising fact number 6, time might reverse at singularities. Now, let's dive into the rabbit hole of time reversal. Some theories suggest that once you cross a singularity, time as we know it may flip on its head. Imagine this: all the moments that led you to this point start to unspool, like a film reel running backwards. This isn't just a wild notion, it's grounded in the fundamental laws of physics, the same laws that govern our universe. In the convoluted fabric of space-time, a singularity is a point where all the rules we're familiar with cease to exist. And in this realm of infinite gravity, time may not be immune to the chaos. It's like venturing into an alternate universe where the arrow of time points in the opposite direction. So if you ever wondered about traveling back in time, look no further than singularities. So singularities might be the ultimate time machines. Surprising fact number 7. The Big Bang might have been a singularity. Now let's dive into this fascinating theory. The Big Bang is perhaps the most famous event in the history of the universe, the very moment of creation itself. But what if I told you that it might have started from a singularity, a point in space-time where gravity becomes infinitely strong and the laws of physics as we know them cease to apply? Now let's not get ahead of ourselves. What is a singularity? In simple terms, a singularity is a point in space where the gravitational field becomes infinitely strong. This means that if you were to venture close to one, you'd be stretched into a long string of atoms, a process charmingly known as spaghettification. But how does this relate to the Big Bang? Well, the Big Bang theory postulates that the universe came into being approximately 13.8 billion years ago from a state of extremely high temperature and density. That's right. All the matter and energy in the universe was once packed into a volume infinitesimally small. It was a singularity. But here's where things get really interesting. If the universe indeed started as a singularity, then the laws of physics would have broken down at the moment of the Big Bang. This means that we can't actually predict what would have come before it. In fact, asking what came before the Big Bang might be as meaningless as asking what's north of the North Pole. And yet, despite the mind-bending implications, this theory is consistent with our observations of the universe's large-scale structure and the patterns of microwave radiation that permeate all of space. It's a testament to the power of human curiosity that we can even conceptualize such a strange and counterintuitive idea. So the next time you look up at the night sky, remember this: you're not just gazing at stars and galaxies, you're witnessing the aftermath of a cosmic explosion that might have sprung from a singularity, an event so strange and extreme that it defies our understanding of reality. So we might all be children of a singularity. Surprising fact number 8, singularities might be gateways to other universes. Yes, you heard it right. The multiverse theory, one of the most intriguing ideas in modern cosmology, suggests that our universe might not be the only one. Imagine an infinite cosmos filled with a multitude of universes, each with its own set of physical laws and properties. These universes, or multiverses, could be vastly different from our own or strikingly similar. Now here's where singularities come into play. Some theorists propose that the immense gravitational pull of a singularity could warp space-time so intensely that it rips a hole, creating a pathway to another universe. This is purely speculative, of course, but it's a thrilling idea. A black hole, instead of being a cosmic dead end, could be a bridge to an entirely different universe. So, singularities might be the ultimate cosmic doors. Surprising fact number 9, we're still in the dark about singularities. It's a fascinating time to be alive as research on singularities is progressing at an unprecedented pace. Yet the future of singularity research is both exciting and enigmatic, much like the singularities themselves. Current understanding of singularities is largely based on Einstein's theory of general relativity. However, this theory falls short when it comes to explaining the innermost workings of singularities. For this reason, scientists are now placing their bets on quantum gravity, a theoretical framework that seeks to reconcile the laws of quantum mechanics with those of general relativity. Many believe that the answers to our burning questions about singularities lie in the realm of quantum gravity. For instance, it's thought that this theory will shed light on the paradox of infinite density and zero volume that singularities present. Furthermore, it's expected to explain the apparent breakdown of physical laws within a singularity. However, it's not all smooth sailing. Quantum gravity is still in its infancy and faces many hurdles. For one, it's not yet a fully formulated theory, and some of its predictions are still being tested. Moreover, singularities are incredibly difficult to study. They're often hidden behind event horizons, invisible boundaries beyond which we cannot see or gather information. This makes direct observation and empirical testing of theories virtually impossible. Despite these challenges, the future of singularity research is promising. Advancements in technology and computational models are making it increasingly possible to simulate and study singularities. We're also exploring novel ways to gather indirect evidence of their existence and properties. What does this mean for us? Well, it signifies that we're on the brink of a new era of understanding. The mysteries of singularities may soon be unlocked, heralding a revolution in our grasp of the universe and its most extreme phenomena. However, as with any scientific endeavor, each answer will likely reveal a dozen more questions. This is the beauty and the curse of science. The more we know, the more we realize how much we don't know. So the mystery of singularities continues to baffle us. Before we end our journey through the enigmatic world of singularities, let's take a moment to reflect on what we've learned and how we can engage with the subject. We've plunged deep into the mysteries of the universe, encountering mind-bending concepts, paradoxes, and theories. We've explored the incomprehensible nature of singularities, the cosmic censorship hypothesis, the quantum loop, the multiverse theory, and the promising future of singularity research. We've learned that despite the many challenges, scientists are making significant strides in unraveling the secrets of singularities. But what can you do as a viewer? Engage with the content. If this video has sparked your curiosity, or if you've learned something new, don't just keep it to yourself. Share your thoughts and opinions in the comments section. Did a particular concept intrigue you? Do you have a theory of your own? We want to hear from you. And if you found this video enlightening, give it a like and share it with your friends and family. Let's spread the knowledge and inspire more people to delve into the intriguing world of singularities. Don't forget to subscribe to our channel and hit the bell icon. This way, you won't miss out on our future content as we continue to explore the fascinating mysteries of the universe. Remember, science is a shared journey, and your participation enriches the experience for us all. So let's continue this journey together, as we unravel the secrets of the universe, one singularity at a time.